Hello everybody. In this part, we're going to cover linear combination and vector equation. This content is partly from section 1.3 of the text. After this lecture, we're going to know what we mean by linear combination, and we can rewrite the linear combination problem into vector equation and solve it. And essentially the calculation is from Gaussian elimination. All right, we start with the definition of linear combination. So we want to know what we mean by y is linear combination of v1, vp, v1, v2, up to vp. So the definition is following. Let the vector y be given by this math expression, y equals sum of those vectors. For some vectors v1 up to vp, c1 up to cp, then we can say y is linear combination of v1, vp. Or equivalently, sometimes we can say y is linear dependent to v1 up to vp. Those two are the same meaning. All right, from this definition, maybe it's a little bit abstract, but we can recall the vector algebra, the previous class. So we can think of Spider-Man story. So the Spider-Man knows how to move in each step. He knows how to move in v1 direction and how to move vp direction. And the villain or the enemy is in the position of y. So the goal is the Spider-Man wants to catch this villain by using moving skill sets. So for the Spider-Man, if he wants to move to this villain, then he needs to know how many steps he needs to move in v1 and how many steps he needs to move in vp. Those are c1, cp. So c1 steps in v1, cp steps in vp. Finally, he can catch y. If he couldn't catch y, then y is not linear combination of v1, vp. So we can rewrite this question, linear combination question, into y is caught by moving skills v1, v2, vp. All right, let's look at one example. And we're going to fix all 5 vectors here throughout this lecture. So moving skills are given by v1, v2, v3. 3-dimensional space. It's hard to imagine, but each vector stands for one moving skill, and y is a position of villain, and there's another villain, z, at the position 0, 0, 1. Now, we're going to justify if y is linearly dependent to v1, v2, v3, which means you want to justify if you were taught the moving skills v1, v2, v3, and can you combine these moving skills to catch this y? All right, here's a hint. Why not move 2 steps in v1 and 1 step in v2, 1 step in v3? Let's check. So 2 steps in v1, 1 step v2, 1 step v3, which means 2, 1, 0, 0 plus 0, 1, 0 and 1, 1, 0. That gives exactly 3, 2, 0, y. So the answer is yes. Y is linear combination of V1, V2, V3. Now another question is, can we catch Z using this moving skew? We're going to leave this question to the end of this lecture. Vector equation. In this slide, we're going to tell you how to justify a general question about linear combination. So the question is, so we said, here is the statement. We have 3 equivalent statements. So using this statement, we are able to justify the linear combination. So the question is, y is linearly dependent to v1, vp. So to justify this as true statement or not, what you want to do, by definition, what you want to do is solve following equation. x1 v1 plus up to xp vp equals y. So which means in this vector equation, this is called vector equation. In this vector equation, what you want to find is the step size x1, xp, x1, x2, xp. So if you could find those numbers for each xi, then this means the villain y is caught by Spider-Man using this moving combination. So the statement says, vector equation, if the vector equation is consistent, then y is linear combination of v1 up to vp. If vector equation is not consistent or has no solution, then y is independent to v1 up to vp. Then for the vector equation, the question is how to solve it, how to find x1 up to xp. The answer is using augmented matrix. We have to justify following augmented matrix is consistent or not. So we pack all the moving skews together, v1 up to vp, and with the vertical line, write the villain's position y here. This is augmented matrix, and we try to understand this augmented matrix is consistent or not. Then that means we have to use Gaussian elimination, make it to RREF or REF. Now let me try to answer this question. So solve augmented matrix v1, v2, v3, y. So we have to go back and copy So we have those things. I want to know if y is linear combination of v1, v2, v3, and this means the question is the same as, is augmented matrix with v1, v2, v3 skew set, And after line, you should write the villain. Is augmented matrix consistent? Now, that means you want to look at Gaussian elimination. So V1, V2, V3 is given by 1, 0, 0, 0, 1, 0, 1, 1, 0, and 3, 2, 0. And this is a relatively simple augmented matrix. We're going to use Gaussian elimination, which means we have to focus on first non-zero leftmost column and identify pivot. And then next step, this is the second column is pivot. And the last row is 0. So basically this is REF. So we can put the staircase like that. It is already in REF. So probably we don't need any more. We don't have to bother with if the further Gaussian elimination from backward elimination, it can convert to RREF. So we are not going to compute for REF. REF is enough to identify that. And is it consistent? Then that means is the last column equals non-pivot? The answer is yes. Therefore, augmented matrix is consistent. Therefore, Y is linear combination of V1, V2, V3. All right, next we're going to look at another question, which is about Z. So the question is Z linear combination of V1, V2, V3? And for that, we want to ask, is augmented matrix 1, 0, 0, 0, 1, 0, and 1, 1, 0, and the other side is villain's position, consistent? The answer is, well, if I look at this augmented matrix, we can immediately identify pivot, and it's already in REF form. So, oh, there's another pivot, which is in the last column. So, we have a staircase like that for the REF. And if this is REF, we don't bother with RREF. We can immediately ask how many solutions are there. And because last column is pivot, so augmented matrix is inconsistent. That means Y is independent. to, or not linear combination, V1, V2, V3. That's pretty much everything about linear combination. So recap. We want to know if Y is linear combination of V1, V2, V3. Then what you do is V1, we can put the skill set on one side of the line and the other side just villain and is consistent. Then to do that, to identify that, you want to try to reduce this into REF and look at its last column. And consistent means it's non-pivot. Of course, for REF, you have to use Gaussian elimination if the augmented matrix is complicated. Thanks for watching.